Hello friends, today I will show you how to implement binary search tree using JavaScript. So let's start with it. Now let's see the implementation of binary search tree and its traversal. So firstly we'll create one node. So class node, it will have three properties: constructor, one will be data, this dot data equal to data, this dot left equal to null for now, which points to the left child of the node, and this dot right equal to null, which points to the right of the node. So let's create one class named as binary search tree. Now the constructor will have one property, which is it will keep the root of the binary search tree. For now it's null. Now let's insert an element into this binary search tree. So let's say we are inserting this data. Now we will create our object for that node to hold this data. New node and hold this data. Okay. Now if our root equal to null, that means we are having no any node in our binary search tree, then we will push this particular data into it. So this particular node which we have created right now, else we will have a condition checking. So for that purpose I am taking to a separate function, and this function will named as this dot insert node, and it will take two arguments. First will be this dot root, the parent node, and the node which is the newly added node. Let's give the name as new node, which will be easy enough to distinguish. Now we will get this particular function. So insert node, it will have two things, one is root, another is new node. Actually here the name is node only, because we have declared over here node. So here is a new node, root and new node, we are taking it. Now we are checking that if new node dot data is less than root dot data, then we are doing something in this if condition. Else we are going for this condition if new node dot data is greater than root dot data. The first condition for the left side, that means left subtree, and the second condition is for the right subtree. So if data is matching with the root data, then we are not doing anything because we are avoiding the duplicate elements for this binary search tree, taking as a assumption. So now in this particular thing over here in the left subtree, we will see if root dot left equal to null, that means we don't have any data into the left side, then we will directly push that particular data to the left. So root dot left will be our new node. Else if we have some data, then we will do a recursion. So this dot insert node, now we will go to the leftmost to the left of this particular node, and we will do the same thing in the recursion. So root dot left comma new node. Okay, we will do the same thing for this right side. So if root dot right equal to null, that means we don't have any element in the left side, in the right side, then root dot right equal to new node. Else if we have some data, then we will find the last node so that we can insert the newly node into it. So we will go for recursion. So this dot insert node root dot right comma new node. Now this is okay. So this is the way we will insert. Now let's see how we will traverse this particular search tree. So first of all, to traverse this particular search tree, we need to know the root node. So we will have one function to get the root node. So get root node I hope you can see it. Okay, so this will just return this dot root. Now we will go for traversal. So first traversal we will go is preorder. Okay, we have the root node as a parameter, as an argument. Now if root not equal to null, that means we have some elements in our binary search tree, then console.log root.data. Actually, pre-order, in-order and post-order have only 3 lines difference. So let me show you what that 3 lines will be there. So this is the first line. This is the first line. Now comes the second line. This dot pre-order root dot left. Then we will go for the left side. This is the second line, which is changing, which will change in different traversal, and this will be the third line which will change. So preorder root dot right. So this is the third line. Now these three lines only will change for traversal in different kind of traversal which we do. So this is preorder traversal. Now for the second case, we will take Inorder Traversal. So let's change the name. Inorder, and then this console part, no, the printing part, this will go in the middle. Now let me take it this entire line. Okay, this will go in middle. That means now this become first line, this is second line, and this is third line. Okay, now let me change over here the function name, and here. That's all, nothing more we need to change. Now in preorder it will have like this, that first it will traverse parent node, then it will traverse left child, then it will traverse right child. So this is the flow it will execute. For Inorder, first it will go for left child, it will kind of explore the left child, then it will explore the parent, and finally it will explore the right child. So this is how, this is the second line, this is the second type of traversal. Now let's see the third type. I have copied this, and here I am pasting it. Okay, now this is the post order. The name is Postorder. As we see the name, we have conclusion in our mind that this console log will go at the last. We will print at the last after everything has been done. So every kind of node that left right has been traversed, then the parent will be traversed. So it will be, this line will go into the last portion. So this is how it will come here, and this is okay. Now this becomes the second line, this is the third line, and the sequence will be like this. First we will traverse the left, then we will traverse the right, then we will traverse the parent. This is the sequence. This is the preorder. Now we will see how we will display the result with this implementation. So we will create an object for binary search tree, bst new binary search tree. So now we will insert some element. Insert, let's say we are inserting 3, bst dot insert, let's say 5, bst dot insert, let's say 1, bst dot insert, let's say 6. one more. Let's see. Insert, let's say 4. Now we have already a function which will give us the root of the binary search tree. So bst dot get root node. So we will get the root, so we can easily do preorder, inorder and postorder. Now let me do a preorder. So this will be the preorder, bst dot preorder and root. Now I'm giving some line spacing, so /n to leave a line, and then we will do for the next, which will be in order. Next we will have post order. Now let's see how it will give the result. Now let's run it. This is what coming. This is the pre-order, there goes in order, and there goes post order. Now I am showing over here the actual tree representation which used to be in the memory. Right over here we cannot distinguish so properly, so I am showing this particular diagram which you can easily distinguish the difference, what is there and what is the difference between pre, in and post order. That's all for this video. Thank you.